Welcome to Ask and Learn.
All right, let's do this problem. So the question is asking you, you have the integral right here. Describe what it is. Like it's an easy question, right? It takes a lot of practice and experience for anyone to be able to really be able to tell what this shape is. So I am going to give you the hint of how you solve these kind of problems. And there are many ways to do it, of course, but it's just an idea that would probably help you how to do it. Okay. Now, the approach that I like to take is that I see that there is a pi in something squared. Okay. So that should remind you pi r squared. So a pi r squared is basically the area of a circle. So that's the biggest hint that you have here, okay? Furthermore, when you have a dy, you basically have a very, very small difference of y's, telling you that it probably came from pi r squared delta y, which is actually a thin disk with radius r that looks like this. Okay, and then you're integrating it from -1 to 1, which is one of the process of integrations. So you're probably going to get a shape that looks like this. Where you cut through it, it looks like a circle. And then each of these thickness is dy. And these coordinates starts from -1 to 1. Okay, so that's the basic big picture of what's going on here. And if you remember, this is actually one of the formula that you use in calculating a shape revolved around an axis. So for example, if you have a graph that looks like this, and then if you revolve around it an axis, you can get a shape that kind of looks like that. Okay, so this is what's really happening. The input is a y, and truly speaking, it really doesn't matter, but I think the book wants you to think about it this way, so I am actually going to go through it. 1 minus y squared. If I said x is equal to 1 minus y squared, x is a function of y is not a function of x. So if you graph it, it's actually going to be a sideways parabola that looks like this. -1 to 1, it goes through 1, and it's a parabola that looks like this. Okay, so the distance from here to there, given a value of y, it is going to be 1 minus y squared. And this is going to be treated like the radius that I mentioned right here. So when you revolve around the y-axis, the solid that you're going to get is going to look like this. You will have a radius with respect to y, which is equal to 1 minus y squared. This is going to be a change in the y values because it's a very thin disk. And then you're going to take the integration or sum it up from -1 to +1. So if you add up all of the thin disks, it would look like, I would describe it something like a lemon shape or a rugby ball-like shape where the radius is precisely 1 minus y squared. So something like this. Okay. So I know my drawing is not the best, but that's exactly what we're trying to describe in this integral, and that's how you solve these problems.